So what we're covering today is when we're solving for absolute value equations. So we have one that we're doing equations and then one we're doing inequalities, okay? This is kind of a lot, so this is a good thing that you can go back and watch it again if you need to. Now, when you're solving any absolute value, you have to remember, what does an absolute value mean? Absolute value means it's a distance from zero. So generally speaking, that distance from zero could happen two places. It could happen here or here. So let's just say, like, I always give the example, what's the absolute value of 3? And everyone says 3. What's the absolute value of -3? 3. So both of them were the same absolute value. There was two different things that could have been that. So when you're solving these, you will have two answers. Very rare will you end up with the same answer. I'm trying to see if it's at all on your page. Nope. So all of these will have, one. All of these will have two answers except for one where it happens twice, the same answer, which is called a double root, but you will get into that in Algebra 2. So let's just go ahead and start. I'm gonna do some examples for you. So remember, the first step is to get the absolute value by itself. Okay, you have to get, and this means absolute value bars. Those are those bars. It's not an 11, it's an absolute value bar. You have to get those absolute value bars by themselves. After you get them by themselves, set up your two problems. Okay, so you set one equal to a negative and one equal to the positive. Oops, sorry. So one is going to be set equal to a negative, one's going to be set equal to positive, and then you just solve both. Okay. So get the absolute value of the bars by themselves. After they're by themselves, okay, same junk in the absolute value bars equals the positive answer. Same junk in the absolute value bars equals the negative answer. Okay, so let's try some of those. So are the absolute value bars on this side all by themselves already? Yes, there's nothing on the outsides of it that I have to take care of. So step one is done. Okay, step one is get by myself, done. Step two, set up two problems. So you take the junk in the bars, so the 3x equals the positive answer of 9. That's one of them. Then the junk in the bars equals the negative answer, because remember, we have two answers for each. Okay, now that we have our two problems, we're just going to keep solving them. We're going to solve this one, and then we're going to solve that one, and then we'll have our two answers. So how do I undo that? I divide by 3. So x is 3. That's one of my possibilities. Divide by 3. X equals -3. So my two answers for number one could be either 3 or -3. And if you plug it in, it makes sense. So 3 times 3 is 9. Absolute value of 9 is 9. If I put -3, 3 times -3 is -9. Absolute value of that, distance from 0, is 9. So you have two answers. Now, a lot of people are going, I'll just solve one and put a negative on the other. That doesn't always work, okay? So what you need to do is you have to do it the way I say it. You have to do get the absolute value bars by themselves, then set up your two problems, then solve, okay? Absolute value bars by themselves, set up your two problems, then solve. So let's just try another one. Let's try number 6. Okay, number 6, does it have anything on either side of those absolute value bars that I need to take care of first? No, step 1's already done. The absolute value bars, there's nothing on either side of them, so we're good to go. Okay, so step 2 is set up your two problems. So the junk inside the bars stay the same, so -4 plus 5x equals the positive answer. And then -4 plus 5x equals the negative answer. Okay, now you set up your two problems. That's done. Now step 3, solve them both. So I'm going to add the 4. So I have 5x equals 20. Divide by the 5. X equals 4. Okay, add the 4. 5x equals -12. Divide by the 5. X equals negative 2.4. It's okay to get negatives. It's okay to get decimals. And did you see, these are not the same answer. Okay, so that's why I'm saying you have to use the process that I'm telling you. So one answer is 4 and the other one's negative 2.4. A lot of people get 4 and then they'll try to put negative 4. That is not correct. Okay, let's try number 10. Are the absolute value bars by themselves? No, not this time because I see a -5 here. So the first thing I have to do before I can set up my two problems is get them by themselves. So I'm going to get rid of that. So I'm going to add 5. Whatever I do to one side, I have to do to the other. That's gone now. Now I have the absolute value of v plus 8 equals 7. So now I can set up my two problems because my absolute value bars are by themselves. So I have v plus 8, junk in the bars, equals 7. V plus 8 equals -7. Okay, solve for both. Subtract 8 here. V equals -1. Subtract 8 here. V equals -15. Again, not the same answer. Okay. Absolute value bars by themselves. Set up your two problems. Solve them both. Okay. Now I am going to do a couple examples on the back side. Something I wanted to mention, it doesn't happen on this worksheet, but I want to mention it so that way if it ever did happen, you guys could know the answer. So let's just say we're looking at this problem here. And if this was a -30, could an absolute value ever equal a negative number? No, because it's a distance. You can't go -2 miles today. Okay, that doesn't make sense. So if you had an absolute value all by itself and you had equals a negative number, you would put no solution because it doesn't make sense. Okay, just wanted to mention that. It doesn't occur on this worksheet, but it might occur in the quizzes. I haven't looked that far ahead. It might occur on the test. I don't believe I did that, but it's possible. I might have, I can't remember. Okay, so let's do 2 more examples. We'll do 17. Okay, so you have to ask yourself, is the stuff in the absolute value bars by themselves? Well, no, I see this 2, I see this 5, lots of things going on. Now, a lot of people want to take and go 2 minus 5, that's 3. No, because order of operations is saying this 5 is getting multiplied against that absolute value. So you can't just say 2 minus 5 right there, 3, -3, we're good to go. No, 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 no. Okay, so that 5 is getting multiplied. You cannot do that. So what I always say is like, it's like solving for a variable. Cover up that junk in parentheses. Well, technically that 5 is attached to it because it's multiplying. So how do I get rid of this +2 first? Well, I would have to subtract 2. Okay, so now I have -5, absolute value of 5m minus 5 equals -73 minus another 2 is a -75. Okay, now how am I going to get rid of that -5 that's multiplying against those absolute values? Well, the opposite of multiplying is dividing. So I'm going to divide by -5. Okay, so I have absolute value of 5m minus 5 equals -75 divided by a -5 is 15. Okay, now are my absolute values by themselves? They are. So now what I'm going to do is I'm going to set up my two problems. So I have junk in parentheses, so 5m minus 5 equals the 15. And then I have the 5m minus 5 equals -15. And then I'm going to keep solving. I'm going to add 5. So I have 5m equals 20. So m is 4. That's one of my answers. Add 5. 5m equals -10. Divide by 5. M is -2. So I have 4 and -2. Okay, one more for safekeeping, and then I'll let you guys start working on it. Again, are the absolute values bars by themselves. They're not. So let's cover this part up. How do I get rid of that minus 3? Add it. Now that's gone. So I have 3. Absolute value of 3 minus 5r. Okay. Equals 18 plus 3 is 21. How do I get rid of multiplying by that 3 on the outside? Divide. Okay. So I have absolute value of 3 minus 5r equals 7. Absolute values are now by themselves. So now I'm going to set up my two problems. So I have 3 minus 5r equals 7. And I have 3 minus 5r equals negative 7. Keep solving. How do I get rid of that 3? I subtract it. Negative 5r equals 4. Divide by negative 5. You could leave it as negative 4/5, or you can say r equals negative 0.08, 0.8. So 0.8. Okay, or you could have left it as negative 4/5. Subtract the 3. So I have negative 5r equals negative 10. Divide by negative 5. R equals a positive 2, because a negative divided by negative is a positive. So two answers for that are negative 0.8 and 2. I am here if you need me for those. Let's look at the inequalities now. Okay. Inequalities, same process, but we're also going to graph them. Okay. So we're going to do a few from here, and then I'm going to kind of overwhelm you, and then I'll let you start on them. Okay. So number 3, same process. We get our absolute values by themselves. Okay. Set up our two problems, solve them, and then we're going to graph them on top of it. Okay. The only other thing is absolute value by themselves. Okay. Set up two problems. The other thing on this is when you set up your two problems, on the negative one, you must flip your sign. So we're adding another layer on there, okay? So just like when we divide by a negative, we have to flip our sign. When we set it up, when we have one same sign positive, this one opposite sign negative, okay? So when we take care of the negative one, we flip the sign. And then solve and graph. Okay. There's not a lot of room on this worksheet, but I'm going to try my best to make do with what I got. Okay. So we'll just start with, let's do number 3. Okay. Are the absolute values by themselves? Yes. Now I'm going to set up my two problems. So I have junk in parentheses. So m minus 2. Now I leave the same sign, 8. That's one of them. And then I have m minus 2, which is junk in parentheses. Opposite sign, so we're going to flip it, negative 8. So flipping it just means that it was facing the 8 before, now it's not facing the number, okay? So when we take care of the negative one, we flip that sign. Now we're just going to solve the 2. So I'm going to add 2. So m is less than 10. Add 2 here. M is greater than negative 6. So open or close circle at 10, open. Less than is pointing to the left. Open or close circle at negative 6, open. Greater than is pointing to the right. So these are actually going to connect. Sometimes they'll connect, sometimes they'll both be facing in the same way, sometimes they'll be facing opposite ways. Okay. Let me look through the worksheet. Yep. Okay. So that's how you do like number 3. Let's look at number 7. I'm going to do a few with you so that you get the hang of it. Is the absolute value by itself? No. I have to get rid of that minus 3 first before I set up my two problems. So I'm going to add 3 to both sides. So I have absolute value of r is greater than 5. Now is the absolute value of by itself? It sure is. So now I'm going to set up my two problems. So junk in parentheses, so R, same sign, 5. Junk in parentheses, R, opposite sign, -5. Those are already solved. I don't have to solve anymore. So open or close circle at 5, open, and that's pointing to the right because it is greater than. Remember this little trick too? Because our variables are on the left, we can use that trick. R is less than -5, open circle at -5, is less than, so these are pointing opposite of each other. Open circles pointing opposite of each other. Okay, let's try another one. Let's try 11. Is that absolute value by itself? No. So I need to take care of that 1, subtract that 1 over. So I have absolute value of 1 plus b is less than, what's 4 minus 1? 3. Now the absolute values are by themselves. Now you set up your two problems. So junk in parentheses, the 1 plus b, same sign, 3. 1 plus b, opposite sign, -3. Okay, subtract the 1. B is less than 2. Subtract the 1. B is greater than -4. Open or close circle at 2. Open. Less than is pointing to the left. Open or close circle at -4. Open. Greater than is pointing to the right. These will connect. The good news with this worksheet is that if you get a number that's not on this number line that they give you, do it again because you did something wrong. That's the beauty of this worksheet. Okay, let's try 13, just to give us a little more practice. Is the absolute value by itself? Yeah, it actually is right away. So we're going to set up our two problems. 10p minus 4 less than 34. 10p minus 4 greater than -34. Because remember, we have to flip the sign when we do the -1. Add 4. And 10p is less than 38. Divide by 10. P is less than 3.8. Okay, add 4. 10p is greater than -30. Divide by 10. Now, same rules apply. If this was a -10 and I was dividing, I'd have to flip that sign. But because I'm not dividing by a negative, I'm dividing by a positive, I don't have to. So I need to mention that because I feel like you have to remember that those still apply, all those rules. Okay, so I have p is greater than -3. Open or close circle at 3.8. Well, 3.8 is almost a 4. Open circle. It's less than, it's pointed to the left. Open or close circle at -3. Open. Pointing to the right because it's greater than. So those are actually going to connect too. Okay. Just because I feel like we need to, we'll go through probably 3 more. 17, let's look at that one. Is the absolute value by itself? No. So cover up that, I have to add that 10 over. So I have 9 absolute value, m minus 8 is less than, if I add 10, that's 36. Is the absolute value by itself? No, it's still not by itself because that 9, got to divide by 9 on both sides. So I have absolute value of m minus 8 is less than 4. Okay, now it's by itself. Set up your two problems. So I have m minus 8 less than 4, m minus 8 greater than -4. Okay, add 8. M is less than 12, add 8. M is greater than 4. Open or close circle at 12, open, pointing to the left. Open or closed at 4, open, pointing to the right. Those are going to connect. Okay, let's try 19. 2 more and I promise I'll let you work. Got to get rid of that. I got to add that 10 over. If I add 10 to a -73, I have 9 absolute value of r minus 2 less than -63. Got to get rid of that 9, divide by 9. So I have absolute value of r minus 2 is less than -7. Okay. Well, never had this issue yet, have we? We've never had a negative when we start. So I'm going to read this to you. An absolute value is less than a -7. Does that make sense? Would a distance ever be less than a negative number? No. Doesn't make sense. So this one is no solution. An absolute value, a distance could never be less than a negative number. That doesn't make sense. It could be a 0 or any number higher than that. Okay? So no solution for that one. Now let's go down to 23. Subtract that 8. So I have 4, absolute value of 6 minus 2a, less than or equal to 24 minus 8 is, did I do all of that? I hope so. 24 minus 8. I had a brain freeze there for a second. 16. Good grief. Okay, divide by the 4. Absolute value of 6 minus 2a is less than or equal to 4. Now the absolute value is by itself, so now you can set up your two problems. 6 minus 2a less than or equal to 4. 6 minus 2a greater than or equal to -4. Solve. Minus 6. -2a is less than or equal to -2. Gotta divide by a negative. If I'm dividing by a negative, what do I need to remember? I have to flip my sign, so I have a is greater than or equal to 1. It's one of my answers. Subtract that 6. So I have -2a is greater than or equal to -10. Oh, I'm dividing by a negative again. I need to remember to flip my sign again. And I have a is less than or equal to 5. Open or close circle at 1. Close circle at 1. I'm going to erase this because it's in my way. Pointing to the right because it's greater than. It's a closed circle. Pointing to the right. Open or closed at 5. Closed circle. Pointing to the left. Those are going to connect. Okay, one more problem. This one. Cover that up. How do I get rid of that 3? I got to subtract it. So I have 4 times the absolute value of 3x plus 7 greater than or equal to, if I subtract that 3 to that 89, that is 89, 90, 91, 92. Divide by 4. Divide by 4. I have absolute value of 3x plus 7 is greater than or equal to negative, what's 92 divided by 4? 92 divided by 4, 23. Okay, before I start and make my two problems, again, I have a negative on this side. Okay, so it's either going to be probably a no solution or all real numbers. Okay, remember when we have that, that's probably going to be our issue. So it's saying a distance is always greater than or equal to a -23. Is it always greater than a -23? Yeah, it's a distance. So that actually makes sense. So this is all real numbers. Or infinity. Oh, if it's all real numbers, it's all of them. That's how you graph that. So a lot of information, but I'm here if you need me, and you can rewatch the video.